All right, gang, we are back with some quadratic formula examples. If you made it through the quadratic formula derivation, good for you. You should have. Wasn't that bad. We're going to do some examples real quick. So I'm going to go straight to the notes. I'm going to move my face. Let's get out of the way. So I'm going to put myself way up there in the corner, heading over to the screen. Let's do a couple problems. Remember, this works for any quadratic formula that's in standard form. So number one on your notes is already in standard form. You can ignore all this stuff at the top. You can watch that YouTube video if you want. It's a little girl memorizing the quadratic formula. The point being, if a 2-year-old can do it, then you guys can do it. So here we go. Number one is already in standard form. And so all I like you to do before you start is this. I like you to write down A is 2, B in this case is -1, and C is 4. I like you to write those down because it just makes it less likely that you will make a plug-in mistake when you use the formula. And so I'm going to do this very fast because I don't want to insult your intelligence. I'm pretty sure you can use the quadratic formula, but let's just go through quickly. So here we go. Opposite of B, well, B is -1, so the opposite of B is 1. You have to write that. Don't forget you have to put the 1 there because watch what's going to happen. 1 plus or minus something is not the same as just plus or minus something. There's an extra 1 being added. So you got to have that. Under the root sign, b squared, so -1 squared is 1 minus 4ac. It's just plug and chug, all divided by 2a. Take a close look at that, see if you agree, see if you like it. I think you will. All right. Most common source of mistakes when using the quadratic formula, in my humble opinion, is under the square root sign, figuring out if you are adding or subtracting. Now, in this case, it's easy. There's only one minus sign, so we're clearly subtracting. But when there's 2 minus signs or 3 negative signs, then we get people that do it wrong. So we must be careful under the square root sign. Here's what we got. 1 plus or minus. Let's do some arithmetic under the root sign. I've got 1 minus that thing. So 1 minus looks like 32. 1 minus 32, did I do that right? Is -31. And my denominator here looks like it's a 4. So there's what we got. Now, are we finished? No, we're not finished because we have something under the root sign that can be simplified farther. Anytime you have a negative, you can certainly yank out an I. So here's what we're going to have. We're going to have 1 plus or minus, looks like I root 31 because 31 doesn't break down any farther, all over 4. Now, is that a messy answer? Kinda, yeah. Are those real answers? No, I got I in there. So in other words, this particular quadratic right here that we started with, this one right here, there's no real number in the world that you can put in place of x and have that sucker work. There's none, 0. But we have 2 complex numbers that make it work. So I don't want you to do this because this would break you if you tried to do this. But you could take these answers. So let's take one of them. 1 plus I root 31 over 4. That's one of the answers. And you could plug it in for x here and x here. And theoretically, if you didn't make any algebra mistakes, you would get that to work out to equal 0. Now, we're not going to do that. We're going to trust that we use the formula correctly. So these 2 answers for number 1 were complex, not real. All right, let's do number 2. Let's go quickly. Number 2 is not in standard form. You got to get it in standard form. So let's add x squared to both sides. Let's subtract 4x from both sides. Now take a look at that. I went kind of fast, but I made sure to put it in standard form in the right order. You got to make sure you put the x squared first, the x second, and the constant third. I don't know, little tip, everything's divisible by 2. If you wanted to, you could divide by 2. Certainly don't have to, and you can reduce at the end. But I like to make things as easy as possible, so I think I'm going to divide everything by 2. 0 divided by 2 is 0. So here's my quadratic I need to solve. And let's just plug and chug. So let's see, here we go. X, I was a bad example. I didn't write down my A, B, and C yet. So there's A, there's B, and there's C. All right, here we go. X equals opposite of B, which looks like it's 2. B squared -2 squared is 4 minus 4AC C all divided by, I'm going to do this in my head, 2 times A. Well, 2 times 2 is 4. That's in my head. Yep, 2 times 2. All right, so here's a place where people make some mess ups. Under the root sign, look at this, look at this, look at this. You have a minus sign and a minus sign. Well, that's 2 negative signs. And 2 negative signs, you know this, cancel each other out. So do not, for any reason, subtract. Those negative signs are gone. So under the root sign, I have 4, and the rest of it is 4 times 2 times 1, which is 8, and I'm adding. Don't subtract. There's 2 negative signs. It's a very common mistake, and I don't want you guys to do it. All right, here we go. So I have 2 plus or minus square root of, what did we just say? 4 and 8, and we're adding, that's 12. All right, reasonable. This one's a little different because, oh, I'm out of room. This one's different because the 12 can be broken down farther. It is not simplified. You guys know the square root of 12. I know we worked on square roots the other day. Come on, 2, erase, erase. I don't know why my eraser doesn't seem to want to work. There we go. Okay, so let's break down root 12. I'm going to do it over here. So x equals 2 plus or minus root 12 is this. And we're almost done. That's an okay answer. That's like saying 4/8 for an answer. 4/8 if the answer is really a half. It's not wrong. It's just not simplified, right? So in this particular problem, all 3 of my terms are divisible by 2. All 3 of my terms. So the 2, the second 2, and the 4. All divisible by 2. Now look at that answer. There is one extra number that I wrote in that answer that I don't need. I want you to think about that. I need the first one. I don't need the second one because it just says 1 times root 3. Well, 1 times root 3 is root 3. So I could have written this answer without the second number 1, but I certainly need the first number 1. Okay? I'm going to tell you a common mistake that people do. Here's what they do. They get to this part and they reduce the 2 and the 4, but not this guy. You cannot do that. If only 2 of the 3 reduce, you can't do it. It's got to be all 3. Okay? All right, so that's 2 pretty quick examples on the quadratic formula. You should have followed that just fine. Shouldn't have any questions. The only thing remaining today is this. I'm going to sit down and talk to you. The only thing remaining today is this. When you have a quadratic in standard form, sometimes you don't care what the answers are. That's interesting. Sometimes what you care about is, if I were to solve this quadratic, would my answers be real or not? Sometimes that's really all that matters. You're like, boy, I got a quadratic. I sure wonder if it has real solutions, yes or no. And so the first one we did, number 1 right up here, you might recall, didn't have real solutions, but this one did. See, right down there, real. So I wonder what the difference is. And clearly, the difference is, I already erased the first one. My second one had a root 12, and those created real numbers. My first one, if you remember, had a root negative 31. And root negative 31 kind of made me a little bit dizzy. Kind of had to sit down for a second. That gave me really fake answers, complex answers. And so it is the number under the root sign that tells you what kind of answers you're going to have. It tells you. If it's a 12, you're going to have real answers. If it's a negative 31, you're not. So that thing under the root sign, look at the formula, is, I'm trying to do this with my mouse, b squared minus 4ac. So the b squared minus 4ac, that little piece tells you what kind of answers you're going to have. And so let's fill in these notes for just a second. Here's what that first little sentence says. It says, if b squared minus 4ac is positive, so is greater than 0. So if it's positive, like it was in this one, well, then what do you get? You get 2 real answers. All right. What if the thing under the root sign is negative? So if this thing right here, like in number 1 was negative 31, we got fakers, right? We got fake answers. We got 2 complex answers. I'm going to abbreviate. Last case doesn't happen all that often, but it certainly does. What if that number under the root sign is 0? So what if we got down to something and it said x equals 4 plus or minus the square root of 0 over, I don't know, 10, something like that. Well, the square root of 0 is 0. So really what this would then say would just be 4/10, yes, or 2/5. So in this one particular case, if the number under the root sign exactly equals 0, we get one real answer. Now we get it twice, it's called a double root, but it's still only one unique answer. We get one real solution. So this number under the root sign is really an important number. It has a name. It's so important it has a name. It's in your notes. It's called the discriminant. And here's why it's called the discriminant. It discriminates, which is generally a bad thing, but in this particular case, helps us. It discriminates between quadratics with real solutions and quadratics with fake solutions, with complex answers. So it's called the discriminant because it helps you discriminate what type of answers you're going to get. All right. So the last thing we would do is I would just take a quick problem. We're not going to do both of these, but let's just do number 3. Here's the question. You don't need that picture, really. Here's the question. How many solutions are there and what type? It doesn't say find them. It doesn't say what is X. It says how many solutions are there and what type. So here's what I would do for number 3. I'd write down my A, I'd write down my B, I'd write down my C, and I would say, how many solutions and what type? They're asking me about the discriminant. B squared minus 4AC. Hey, look, 3 negative signs. Well, 2 of them cancel each other out. So pick 2, I don't care. And so this is a subtraction problem. So this one's going to say 16 minus something. 4 times 1 times 3 happens to be 12. And so my discriminant is 4. By the way, my discriminant is not the square root of 4. My discriminant is 4. The discriminant is the number under the root sign, not counting the root sign. It's just the number underneath. So since my discriminant is 4, I'm going to have what? 2 real answers. That's it. That's all we're doing with this problem. I don't even care what the answers are. I just know there's going to be 2 of them, and they're real. All right. So gang, we don't love the quadratic formula. I mean, it's nice. It's a great thing to have in our pockets. You don't want to use it unless you have to. But you certainly can if a quadratic is in standard form. If it's not in standard form, y'all got to put it in standard form. And then the other important topic from right now was this thing called the discriminant. So make sure you watched the whole thing. Make sure you understand what the discriminant tells you. Do your homework like a good person. Hope you got something out of this video. And I will talk to you next time.